Hi! In this video, we'll be talking about operator overloading. So let's review what we've seen so far with the point class. We've seen that we can define the init method, and that allows us to define the behavior that happens when we create a new point. So we can make an init method that sets the point's x and y attributes. If we pass a 3, 4, that'll make a point with an x of 3 and a y of 4. If we pass nothing, it'll use the default values of 0. Now, what happens when we try to print a point? Right now it just does the default repr method, which just produces something not very useful. We just see that it's a point object. But if we override the repr method, we're actually allowed to define how the point will create a string representation of itself. So here, if we define a repr method to return parentheses, the x, comma, the y, and then end parentheses, we can see that when we print p1, we see a usable point. We see a x, y of 3 and 4. Now, what happens when we try to add 2 points? Well, it turns out if you write p3 equals p1 plus p2, if we try to add 2 points together, what we end up getting is an error. We get a type error saying that we have unsupported operand types for add. Add doesn't recognize having a point and a point being added together. So quick terminology here. The plus sign is actually known as an operator. Things like plus, times, divide, minus, these are all operators that take in operands. So here we have the plus operator trying to add together 2 point operands, and it doesn't know how. It doesn't know what to do with 2 points. Well, how can we fix this? Introducing operator overloading. Operator overloading is defining a method to change the behavior of an operator based on the given operands. So we see that the plus operator, the add operator, does something different when it receives numbers versus when it receives strings. When it receives numbers, it adds them together. When it receives strings, it concatenates them. And so we can actually define our own methods to tell the plus operator what to do with our own classes, such as the point class. And we've actually seen an example of this before. We've seen operator overloading with equality. We can define the EQ method that takes the current instance, self, and another instance, and returns whether or not the 2 instances of the point class are equal. So then when we call p1 double equals p2, it's actually calling the EQ method. We are overloading the equality operator. And so here we see that the left operand becomes self and the right operand becomes other. So this is testing if p1 is itself equal to the other point that's passed in p2. And if it is, it returns true. In this case, they are, so it returns true. We can do the exact same thing with addition. We can override the add method, and that allows us to overload the plus operator. So here, if we have p1 plus p2, and we define the add method, then we're having p1 as the left operand becomes self, and p2 as the right operand becomes this parameter other. So behind the scenes, this is really equivalent to calling p1.add p2. But it's much nicer to use the plus operator, so we can actually add 2 points together. So in this scenario, we're returning a brand new point that is the 2 x's combined, self.x plus other.x, and the 2 y's combined, self.y plus other.y. So if we add 3, 4 to 10, 10, we get a brand new point that's 13, 14. We can do a similar thing with multiplication. We can override the mul method, and now we've defined what happens when you use the times operator. p1 times p2 is going to multiply together the x's and the y's. So this is how we can define our own behavior for each of the operators. And what's cool is we can do this for every single operator. We can do it for add, multiplication, subtraction, mod, division, greater than equal to, less than equal to. All of these have built-in methods that you can define to overload the behavior of the operator. Let's see some examples of this. So here we have a complex number class that is used to represent a complex number, such as 5 minus 6i or 3 plus 4i, things like this. So it has a real part, such as the 5, and an imaginary part, such as negative 6i. That is a complex number. And so far, the complex number class implements the init method, which sets the real and imaginary attributes, and it has a repr method, which defines what the string is that's returned when the class needs to represent itself as a string. So if we make 2 complex numbers, c1 and c2, and we try to print them out, this is what we see. We see a 3 plus a negative 4i and a negative 4 plus a 5i. Now, what happens if we try to add together 2 complex numbers? We said c3 equals c1 plus c2, print c3. There we go, we're going to get an unsupported operand type because add doesn't know how to add together complex numbers. So let's fix that. All we have to do is define the add method. So if we do underscore underscore add underscore underscore, it's going to take 2 parameters. One of them has to be self. The other one can be named whatever we want. Generally, we're going to call it other, but we could name it other num. We could name it whatever we want. But let's just call it other. And so what this is going to do is return a brand new complex number that is the two parameters combined. So we want to return a complex number whose real value is self.real plus other.real, and whose imaginary value is self.imaginary plus other.imaginary. And if we do that, we see that we actually added the two together. The real portions were added together and the imaginary portions were added together. And just to show you which one is self and which one is other, we can print out self.real and print out other.real before we add them. And so we see that self is the left operand, other is the right operand. So that's how we can overload the plus operator to accept our own class, such as the complex number. Let's see another example. So now let's come back to the point class. We see that we have the init method, the repr method, and we've defined our own distance to origin method. And that's great, all of these work. But what happens if we want to multiply together 2 points? So let's try p1 times p2. We're going to get unsupported operand types for mult. It doesn't know what to do with points. So to fix that, overload the multiplication operator to accept points. So we define the mul method, take self, and we'll call this one other point. And what we want to return is a brand new point that has, whose x is self.x times other point.x, and whose y is self.y times other point.y. If we do this, there we go. We see 3 times 10 is 30, 4 times 5 is 20. We get a brand new point that is the multiplication of the two. So that is how we can define our own methods to overload the behavior of operators in Python.